Welcome back to my channel everyone and for another video in this C programming course. So today we'll be focusing on data types and variables. So let's get started. So the first part of learning how to do variables is we have to talk about these identifiers. What these identifiers pretty much are, it's just a name. These identifiers are just a different type of name. So what we can just write here, it's just a name, but this name has rules. So, what can identifiers have rules for? There can be names for variables, functions, macros, or other type of necessary units that we need to name. So, an identifier may contain digits, underscores, but must begin with a letter or an underscore. Let me change the color for a little bit more deeper. All right. So, what is a legal identifier? A legal identifier is can contain a letter, a digit, or an underscore, but it cannot begin with a digit. So, any type of legal underscore that I can name a variable can be something like times 15, or I can name that variable A or X or Y. But something that's not legal, something I can't do, is something like 15 times because it said it must begin with a letter or an underscore. Another different type of illegal identifier would be something if it has like a question mark and an X, because this is not legal whatsoever in any sense of an identifier. And be careful because it C is case sensitive. So times 15 is not the same as times 15. So these can be two different types of variables. These are not the same because the C is case sensitive, so it'll view it as a different variable. So there's different ways to write properly or just have proper formatting of these variables. So there's names that, for example, you can have an underscore in the middle to separate words. One example would be symbol. Then we have this underscore table, or we can have current page. You see how it separates the name, the underscore separates the page, or name and address. These are all valid types of identifiers because it uses letters and it uses underscores. So there's something also called it's kind of like a camel casing. You can have the name, but instead of having an underscore, you have every subsequent new letter. The first letter has a uppercase. So nothing has an uppercase except the letter of the new word. An example, a good example would be the name and address. And address. So the first word is not capitalized. The second and third, the letters are capitalized. This is a good way to show or to do some separation in by looking at the variable that this is something different. This is a different name and something similar like that. So, what are exactly variables? So, variables are this type of they store data in program while the program is executing. We need to declare these variables, but what I mean by declare, we need to write a syntax. We need to code in order that we need to create enough memory space for us to store a value in it. You cannot use a variable if you're not declaring some space in memory. And the way we do that is that every variable has a data type. It can be an int, which stands for an integer value, or it can be a double, which stands for a double value. We're just going to focus on these today, just like I say in this next one. Wide variety of types, but we will focus on ints and doubles. And the int data type are used for integer variables, whole numbers. So let's say I have an integer and the identifier, the name of it is times 15. And I want it to store 15. I want it to store the value 15. So this is a good way to do it. So what's happening is that now the variable of times 15 now stores the value of 15. But what if I have a double? If I have a double and I want it to store a decimal number, I can do it the same way, times 15. Let's do times 14, so it's not the same variable. It can hold 7.2. But what if I have an integer times 15 equal 7.2? It won't work because the compiler and the data type for integers only holds whole numbers. So if you try to print this number out, if you try to use this number, where you're going to see what C is going to see, the compiler, it's going to see this as 7, not 7.2. It's going to round down to the nearest whole number, to 7. Same thing for double. Well, not the same thing. It's a little bit different. Times 14. So let's say we have 15. What the compiler sees is it doesn't see 15. It sees 15.0 because doubles represent numbers with decimal places. So the compiler automatically adds this 0.0 right here. So we want to do some declarations of variable examples. So I have a section for integers and I have a section for doubles. So let's write some proper variables that we want to declare. So for integers, I always want to start with int. I'm gonna call it something. Let me call this variable x. Let me call this variable x, and I'm gonna set it to the value of 7. And I'm gonna do another variable z at the value of 6. So here I declared two different variables, one at 7 and one at 6. So if I'm looking at my program from an overview type, z is going to hold the value of 6 and x is going to hold the value of 7. But there's another way that we can declare it. We don't have to declare these separately. What we can do is we can have int declare x equals 7 and have a comma z equals 6. So we are making enough space. So this is what's happening. Let's say this is our memory, right? Let's say this first box over here is x, and this box right here is z. So the value of 7 will be stored in x, and the value of z will be stored in 6. But let's say I never once declared those. Let's say I just put x equals 7 and z equals 6. What happens is this does not happen whatsoever. We didn't declare, we didn't allocate space in memory, so this has nowhere to go. This does not go in memory. This is not stored. Does not store any information. Because it has no place in memory. That's pretty much it. It has no place in memory. We do this step right here and this step right here to allocate some space so we can store some data in that spot. So same thing for double. You can do the same exact thing for double. Let's say this is y let's say it's 7.2, double, let's say W, 6.9. So what we're doing is we're allocating space in memory. Uh, this holds 7.2 because it's my Y, points to my Y, and W holds 6.9. Or I can write it exactly as before. I can just write double once. Y equals 7.2 separated by comma. W equals 6.9. There are also times where I can just write double and Y and just stop it with a semicolon. Or I can do double W, stop it with a semicolon. So what does this do? This allocates space in memory. So what's happening here? It allocates space in memory. I'm declaring Y. I'm declaring W. But I haven't stored anything in it. So I can use these variables later if I want to and update the value of whatever I want to be in here. I can update the value. So in this step, I'm allocating memory for these variables. I don't necessarily have to put an amount of data, a number in there if I don't want to. So we see this a lot in C. We necessarily don't initialize it. There are times when we do initialize, sometimes when we don't. One example is in a for loop. We'll get to that later, but it's very common to initialize a variable and then update the data later, update the variable later. So how do we print these variables, these values? So the way we print them, we use our printf function, of course. Let's use our printf function. And quotations. So for double and integer is a little bit different. For integer, %d is the placeholder. And for %f is the double placeholder. So I'll write it down here. So printf, do I have space? Let's say int x equals 1, int y equals 2. So I'm declaring my two variables right here. I'm declaring these right here. So they have a space in memory. X and Y. So these guys have space in memory and they have stored data in there. So what I want to do is the value of X is %d. This is a placeholder. This is what the value will match up to. Because if I just put 1 and the value of X changes, it's still going to stay 1 in the printf function. So the %d allows it to change, update with the updating value of X. And Y is %d. Why do I use %d? Because %d is the placeholder for an integer value. I close these brackets, and this is where I want to define these placeholders. As you can see, this says the value of X is, so I want this to be X. I want this to be the value of X. So I will declare X, just press X after, write X after the comma. And then for the next one, I want Y. So Y is %d. Close that. And the printed, what it's going to print out is the value of X is 1, Y is 2. So that's what it's going to print. Remember, %d is the placeholder for an integer variable. These are both integer variables. So X is going to map out to this. Since I put X, I set it to be the first one. And the second one, I set Y to be the second one. So initialization, as we've been talking about it, this pretty much just tells the variable what value it's going to be. Just like int height, right over here, we're saying it's 8. So what's happening? We're allocating space and memory in our during program execution, and we are storing the value of 8 in there. So whenever our program needs to refer to height, let's say our program, let's just say theoretical program, right? Let's just say whenever calls height, it finds this value. So, and like I said before, these are allowed to be initialized at the same time. So what's happening here is that height is 8, length is 12, and width is 10. But if we have it as int height, length, and width 10, only width is being initialized. So what it looks like in memory, no value in height, no value in length, only 10 in width. But to compare over here with the one before it, height is 8, length is 12, width is 10. So we're going to declare some variables and print them out. Just do a little example. So let's say we have our int main function. Let's say we have the include up here. We're going to do our directive. We're going to do studio.h. We have our main. We're going to declare, let's say, x, and we're going to say it's a value of 12. Now I want to print it out. I want the program to print out the value of x. So I'm going to say printf the value of x is %d, %d, comma, x, close, and semicolon. Remember, when we declare which variable the %d is, we close the quotation marks before that. We return 0. We close the brackets. Alright guys, it's practice time now. Welcome back. So it's time for a little bit of practice. This is going to be just a little tad difference. I am going to introduce just a little bit of arithmetic of variables and printing it out. If you guys can actually do it, I implore you guys to try. So the question is, well, the program I want you guys to do, so declare x equals 3, declare y equals 2, declare z equals x plus y, and I want you to print out the value of z. So what I want the program to output the value of z is, alright? But I do not want you to write the value of z. I want you to use %d in the printf function. So you guys try to play a little bit with it right now. Try to see if you guys can do it, and now get started. So what we're going to do is we're going to include our directive. Got our studio.h. Header file. We have our int main function. do some space in there. So I'm going to declare x equals, and what was that value that I wanted? x3, y2. x3, then int y equals 2. Another way you can write it pretty much is int x equals 3, y equals 2. So this is pretty much just a comment, so it's not going to affect my program in any way. And what do I want to do? I want to declare int z equals x plus y. Now I'm going to print it out. The value of z is %d because it's an integer value, and integer values use the %d sign. I'm going to go past the quotation marks, comma, z, semicolon, return 0. And that should be it. Let me bring this bracket up. So this is my program. So I'm declaring x to be 3, declaring y to be 2, and I'm declaring z to be the sum of x and y, and then I'm printing the value of z is %d, and I'm declaring that to be z.